Hello, this is a chemistry video, and I've been following the general order of Brown, Burston, LeMay, and Murphy's Chemistry, the Central Science. We're in chapter 5 on thermochemistry, the chemistry of heat. This video is on Hess's Law. Let's get right to it. What is Hess's Law? Hess's Law states that if a reaction is carried out in a series of steps, the change in enthalpy, delta H, change in enthalpy for the overall reaction will equal the sum of the enthalpy changes for the individual steps. Enthalpy is a state function. That means it doesn't matter what path you get from A to B. The difference between the energy at B and A is going to be the same. This is very convenient because let's say that here's an enthalpy diagram. We've seen these before. So here we have methane and oxygen in gas form. And then at the end of the process, we have carbon dioxide and water. All right, now there's more than one way in theory to get from A to B. Perhaps you could go in one step directly, methane, oxygen, bam, we've got carbon dioxide and water. That is going to give off, it's an exothermic reaction, it's going to give off 890 kilojoules of energy to the world. It's a very generous reaction. I'm giving energy away. However, perhaps it could also happen in two steps. Perhaps it could first go to carbon dioxide and water in a water vapor in a gas form. It's not quite the liquid form. So we've got the same substances. We just have this one in a different state. That would give off 802 kilojoules, and then bring it on down into the liquid form of water, another 88 kilojoules, and we're at the same destination. Well, Hess's law states that whether you go from here to here in one big bam, one big step, or whether you take baby steps, you go from here to here, and then from here to here, doesn't matter. The change in enthalpy is going to be the same either way. Well, this can be helpful. So for example, and this is the example they use in the book, the combustion of 1 mole of carbon with a half a mole of oxygen is going to produce both carbon dioxide and carbon monoxide with some carbon left over. The problem is it is impossible, apparently, to measure directly the enthalpy of the carbon to carbon monoxide reaction. We just can't set up an experiment to measure that directly. But dun, 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 in comes Hess's law. And Hess's law basically says, all right, we know this reaction, we can measure this one, from carbon plus oxygen gets carbon dioxide, or carbon monoxide plus oxygen gives carbon dioxide. We know the change in enthalpy for these two reactions. And so even though we can't directly measure carbon plus oxygen gives carbon monoxide, even though we can't directly measure that, we can indirectly know what it is using Hess's law. So let's do it. And the example does it as well. So we know that carbon plus oxygen yields carbon dioxide with a change in enthalpy of negative 393.5 kilojoules. All right, it gives it off. It's exothermic. It's giving it away. We know that. And we know similarly that carbon monoxide plus oxygen yields CO2 with a exothermic reaction giving off 283 kilojoules of energy. All right, so how can we use Hess's law now to find out how to get from carbon monoxide, from carbon to carbon monoxide using these two equations indirectly? So here is how we're going to do it. We're going to take that reaction and we're going to flip the second one, right? Because CO2 is CO2, right? So I can take this and flip it good, and change the sign, because now it's become an endothermic reaction going the other direction. It's taking in energy. Now all I have to do is kind of add these two together, cancel out. It's kind of like algebra, and everything's good. So the carbon it's a lone carbon, so I'm going to end up, if I add these two together, I've got carbon. Now the CO2 on each side cancels out, cancel that. So I'm yielded to CO here. That's the reaction I'm trying to figure out. So if I subtract a half an oxygen from both sides, this disappears and I'm left with a half an oxygen on this side. So by canceling out these two formula together, I get the desired equation. But now all I have to do is add these two numbers together. And so even though I wasn't able to measure the enthalpy of the reaction going from carbon to carbon monoxide, I couldn't find a tidy way of measuring that. Using indirect method and Hess's law, we were able, and they were able a long time ago to figure out that the change in enthalpy for this reaction is negative 110.5 kilojoules. So there you have it, Hess's law in action.